In this question, a university gives z-scores instead of GPAs, and they want us to translate z-scores into GPAs, knowing that the mean and standard deviation of all students' cumulative GPAs are 2.7 and 0.5 respectively. So when we look at the z-scores they give us, we start with 2.0, negative 1, 0.5, and negative 2.5. Now there's a couple ways we can solve this problem. The first would be looking at the distribution. I'm just going to assume it's mound shaped given that it's all students' cumulative GPA and we're at a university. We know that the mean is 2.7 and our standard deviation is 0.5. So if I want a z-score of 2, I know that's 2 standard deviations above my mean. Or in other words, I would add 0.5 to get to 3.2 and another 0.5 to get to 3.7. So when z equals 2, my GPA equals 3.7. Likewise, if I was 1, if I have a z-score of a negative 1, I'm 1 standard deviation below the mean, or 2.2. So when z equals a negative 1, my GPA is 2.2. Now I have z equals 0.5 and z equals negative 2.5. I'm actually going to solve this a second way by looking at the population z-score formula. The z-score formula for population, and the reason I chose population is because, again, of these all students, is z equals x minus mu over sigma. I know my z-scores. X is what I'm trying to find out. Mu is your mean, in this case 2.7, and sigma, your standard deviation, is 0.5. So plugging in 0.5, again I'm looking for x, and to solve this equation I would multiply by 0.5, then add 2.7, giving me a z-score of 2.95, or a GPA rather of 2.95. Now with a z-score of negative 2.5, I'm going to set it up the same way. And my resulting GPA is 1.45. Now, students with z-scores below negative 1.6 are put on probation, and they want us to find the GPA. Again, we can use that same formula where we know our z-score is negative 1.6. We're still trying to find that GPA, or x. Subtracting 2.7 and dividing by my standard deviation 0.5. This results in a GPA of 1.9. So students below 1.9 are put on probation.